Hey, it's time for frictional forces. Don't get me wrong, they can rub you the wrong way. Boy, this frictional stuff, it's rough. I'm telling you, it's one of the slipperiest subjects I've ever studied. Okay, I'm done. You're going to have to know these things. I have no clue why I put jet altitudes on there anymore. I've forgotten. Everything else, it's good. You need to be able to tell me what the normal force is. Connect the normal force to Newton's third law. Calculate the value of frictional forces resulting from the normal force in an object against a surface and distinguish between coefficient of static and coefficient of kinetic friction. These are required to get a passport. You can watch these videos. They're cool. The 100-minute one, seriously, don't. The third law. Okay? Fire a cannon. The cannon puts an action force on the cannonball and the fire. As a result, these kick back. So you push the cannonball pushes you. Recoil is your classic third law. Two forces, two separate objects. Planet Earth is pulling on this mass. The reaction force is the Earth actually gets pulled by the moon. So while the moon goes around the Earth, believe it or not, the Earth rotates on the spot a little bit, sort of like the hammer throw in the Olympics. Now, the normal force is what we call a contact force. The solid surface is between the two, preventing gravity from accelerating the object down, an equal and opposite force is created. So gravity pulls down on this object, but the surface blocks it. The surface has to push back or you begin to accelerate to the center of the Earth. If the force does not exceed the carrying capacity of that surface. Obviously, if you attempt to walk on some snow, it is unable to provide the normal force and you sink. Why is it called the normal force? Normal, orthogonal, right angle, perpendicular, 90 degrees is something math people decided. Well, we need a lot more names than just 90 degrees, so they came up with all of them. Normal gets referred to a lot. You did that in grade 10 in your optics unit. So typically, the normal force and the force of gravity have equal value, but they're in opposite directions and they're from different sources. Now, friction is a contact force. You must actually touch the object in order to have friction. And the friction will always oppose movement. I didn't say acceleration, just movement in general. Okay? The force will always oppose motion and can never help you. And it depends on two obvious things. The force of gravity on the object and the roughness of the two surfaces. This roughness is called the coefficient of friction, and its symbol is mu. The Greek letter, basically an M, mu. Okay? So force of friction is proportional to the normal force here. Now, why is it the normal force, not gravity? You'll see why in a minute. Let's interpret what this mu means. The normal force is really the force of gravity. The force of gravity, its other name, is weight. A 100-pound weight needs a 100-pound force to lift. In metric, a 50-kilogram mass needs mg, 50 times 9.8, roughly 500 newtons to lift. Okay? So really, the force of friction is this multiplier times the force of gravity. This is the drag you would feel, the friction, if you tried to move the object. A 100 Newton drag would feel the equivalent of a 10 kilogram mass. And this friction coefficient has no units. It is a multiplier that basically is telling you what percentage of the object's weight will you feel as drag. So if a coefficient of 1 tells you that it is just as hard to drag it as lift it, a coefficient of 0.2 means it is only 20% as hard to drag it as it is to lift it. And if mu equaled 200, then it would require a shove 200 times the object's weight to make it move. Now let's take an example here to put this in perspective. We have a 50 kilogram object sitting here. The force of gravity on that object is 500 newtons down. This would create a normal force up the same way. I've kind of ghosted it here so it doesn't get in our way of understanding. If I tell you the surface has a roughness coefficient of 0.6, okay? This means that the friction that's going to oppose this guy pulling is going to be mu Fn. This force and the normal force are the same. So this is really saying 60% of the object's weight. Remember, force of gravity is the weight. It's going to take you 300 newtons to drag it. That's only 60% of the force needed to lift it. Dragging this thing is easier. Now let's turn it into an equivalent weight. Let's pretend instead of friction, this is now nice ice, and this 300 newtons of friction is now provided by 300 newtons of matter at the other end. This friction would feel identical to a 300 Newton weight hanging from this object. Since force of gravity is mg, then the mass is going to be the force of gravity over g. A 300 Newton weight would have the equivalent mass of roughly 30 kilograms. The easiest way to do this, when you calculate a friction force, if you just scrub off 1 0, you will get the equivalent weight in kilograms if it was a dead weight hanging.
Hey, Scotty.
Hello.
I have a question. Can you review the